Welcome to my presentation. I am Saurabh Borua. This is my homework too, and topic is key learning from the system engineering for ITS uh, book. So, firstly, I'll discuss about the content. The content covers five topics. Firstly, I'll discuss on the system engineering and is ITS, why it is needed in ITS. Then I will talk about the core principle of system engineering. Thirdly, I will discuss on V model and core life cycle for ITS projects. Then system engineering process in ITS for planning to sustainment we'll discuss. And lastly, agency perspectives and key benefits for system engineering from agency point of view will be discussed. So, firstly, system engineering is transdisciplinary approach. Actually, it combines technology, science, management together, and it purposefully interaction with people, hardware, and software, process, and data, and is a in ITS point of view is a combination of complex systems such as sensors, network, software, vehicle, and users all integrated together in seamless manner. Then prevent common failures such as mismatch needed, say uh, demand side and uh, supply side do not match properly, and lack of integration, tech driven problem, design related problem can be also included if system engineering fails. And core principle of system engineering is from stakeholders' point of view is ongoing needs assessment, concept of operation, which is also known as ConOps. And it starts from define end state to validation, address risks, also delay technology related decisions. Firstly, focus on what and how it will be helpful or benefited before deploying. Because if one system or technology of ITS is deployed, but later it is found that it is not that much beneficial, it will be difficult and costly in both financially and time consume point of view. So we need to define and manage interface clearly, understand organizational structure and for its smooth implementation. So the core life cycle is based on V model, and in IETS perspective, the left side of this model is decomposition, where user needs, requirement, and design are provided one after another, and in the right side we have integration and verification. The steps are build, test, validate, and lastly deploy, and trace the links between both sides. For ITS, we need validation based on real world requirements. There are some alternatives approach such as waterfall for stable projects, incremental or iterative for some project like connected vehicles projects. So within the V models, there can be waterfall or incremental or iterative type system we can consider for the project life cycle. Next, the system engineering process for ITS, that these have six steps actually. Firstly, planning, then development. Next one is integration. Fourth one is deployment. Fifth one is operation and maintenance. Lastly, cross-cutting. Within the planning, we have to know the project scope, ops and requirements. And for development, we have to design and implement. For integration, testing and verification is included. For deployment, we need acceptance by the authority and validation to meet user needs. In operation and maintenance phase, we need sustainment, and lastly, retirement and replacement. For cross-cutting, we need risk management, study, configuration control, traceability, and project oversight is needed. From agency perspectives and key benefit, if we consider that system engineering effort to assess the risk level, pool for high risk and streamline for low risk, and integrate agency process and comply with regulation. Also, early risk evaluation and strong contractor oversight is needed. The system engineering is beneficial in that point of view that early defect detection, it can reduce the rework cost and better stakeholder buy-in. That is, stakeholder can get better benefit, reliable performance, and it is actually proactive than reactive delivery, if we consider. So this is all about the system engineering that I am discussing from the book, and this is the homework two of my uh, home presentation of my homework two. And thank you so much for the presentation. Watching.